Hi everyone, Brendan here. I just want to do a short little video to demonstrate the exercise that we are trying to do in the gallery walk in the class that you're finishing on your own time and you're going to present next week. So let's take a look at that. I have an example circuit on the screen here. So it's not one of the questions you've been given, but it's very similar. And the first thing we're going to do is find the equation for the output x based on the inputs a, b, c, d. So to do that, the first thing I need to do, or that I should do, is just label the inputs here where they go into the gate. So I've got a and b going in there. I've got b and c going into that one. And I've got d going into this one. Then I'm going to look at the output of each gate. So this top gate here is a NOR gate. So that output is going to look like A or B with a bar across everything. So that's what this little bubble here on the end is indicating, that the two inputs are ORed, but that final output is knotted. So the bar goes across everything. And then there's another NOR down here at the bottom. So I've got B or C with a bar across everything. And those become inputs into the downstream gates. So at the top here, I've got another NOR gate, and it's getting A or B NORed and B or C NORed as inputs. So what I'm going to end up with is A or B with a bar on top, B or C with a bar on top. Those two things are ORed, and then a bar goes on top of everything like that. Okay, and then for the bottom gate, which is an AND gate, the two inputs are ANDed. So I have B or C with a bar on top, and I'm ANDing it with D. So let me put a set of brackets just to make it obvious that it's the whole piece that is ANDed with D. Those two things that we have now become the input to this final OR gate. So my final answer is going to be x equals A or B with a bar on top, or B or C bar on top and then bar over all of that, or B or C with a bar on top ANDed with D. Okay, and that's the equation that I'm starting with that I want to simplify. So let me switch pen color here. If I'm going to simplify that, I'm looking for patterns, and I'm looking for patterns that fit this form. So I want to use what's called De Morgan's theorem. Okay, so it's De Morgan's theorem. And you might see it written like this. Okay, or you might see it written like this. Or you might see it written like this. Or you might see it written like this. Okay, and all of these four equations are essentially saying the same thing, that that a gate like this that has a bar across the top can be converted into a gate that has bars on the inputs if I change the sign. So in the case of this example right here, this is an AND gate right there. And that bar on top makes it NAND. I can convert it to an OR gate with bars on the inputs. Okay, and that's really important. So that's how we're able to break apart the circuit. So when I'm looking at the circuit itself, what I'm looking for is things like this big bar on top. And then I know, okay, well, I can change the sign of that gate, get rid of that big bar if I bar the two inputs into that gate, which are this and this. Okay, so let's do that. So I'm starting with x equals a or b whole thing bar, or b or c whole thing bar, bar on top, or b or c bar d. Okay, so that's what I'm starting with again. And the first gate that I'm going to change to get rid of a bar is this one. So I'm going to end up with a or b ANDed now, instead of ORed, b or c. And when I changed the sign of that gate, I did put a bar over the inputs, but because they already had bars, 2 bars in a row will cancel out. Okay, so essentially what I did is I said, I'm going to change this to an AND. I'm going to erase the bar on the output, and I'm going to bar the 2 inputs, but the 2 inputs already had a bar and they canceled out. So I was left with this. And then I'm still left with b or c whole thing bar d. Okay. And then, oh, let me put my bracket in there. Then I can also work on this sign here to get rid of this bar on top. Okay, so that's going to become keeping my a or b, b or c, keeping this or. This is going to become b bar ANDed with c bar and still ANDed with d. Okay, and then the next step in the simplification is for me to multiply through these brackets. I'll end up with AB, so this times this, then I'm going to do this times this, so I'll get AC or BB, and then finally BC or B bar C bar D. Okay, and right away I can see that, you know, B ANDed with B becomes B. And then I can do a little grouping. So I can factor a B out of this term and this term. And what I end up with is B times A or 1. And then I still have my AC, I still have my BC, and I have my B bar C bar D. I do that because I know that this logically works out to 1. Okay, and then I'm left with B or AC or BC or B bar C bar D. And then I do it again. I group this one here and this one here. So I end up with B or 1 plus, or 1 or C, ANDed with 1 or C. I still have my A or C, and I still have my B bar C bar D. So I know that this works out to 1, and I end up with B or AC or B bar C bar D. And you might think that that is the end, but remember, we have this nifty rule 10 that says combining these two gets rid of this term here because it's the inverse of that B. So that will leave me with B or C bar D or AC. And that is actually the final answer for that question. If you want to also see that with a Karnaugh map, we could actually go back to, let me change my pen color here. We could actually go back to this step right here where we have you know, all the inputs as single inputs and bars over single inputs only. and we could start drawing a Karnaugh map. Because we have 4 inputs, I need a 4x4 table to represent this. So I'm going to have AB vertically and CD horizontally. So AB could be 0, 0, 0, 1, 1, 1, or 1, 0. And same thing, 0, 0, 0, 1, 1, 1, 1, 0. Then I fill in my table. So this term here, AB, is anywhere that A and B are both 1, which is this whole row right here. Okay, and then I go to, let's pick a different color here. Then I go to this term here, which is AC, anywhere that A is 1 and C is also 1, which is these two here, but they're already 1, and those two there as well. Okay, so now I have filled in that. The next one is just B. So anywhere that B is 1, which is actually these whole 2 rows here, and the 1 row was already filled in. The next term is BC. So anywhere that B is 1 and C is 1, but because I filled in all the B's, it's these 4, but they're already filled in. Okay, and then the fact that we're covering ground that's already been covered, that's already filled in, definitely tells us that that something can be simplified here. So the last term is, let's pick a different color here, maybe orange. This term here is when B is 0, C is 0, because they've got the bars over them. So that's, and D is 1. So that's this cell here and this cell here, because notice A is not included in this term, so it has to account for both cells where A's value change. So we've got a 0, 0, 1, this one, and then 0, 0, 1 is also this one. Okay, once we have that, we can start doing our encirclements. So I want to circle the biggest group possible first. So I'm going to circle this grouping of 8. Okay, and that, when I'm finding the term that comes from that, I'm going to look at what stays the same in that encirclement. And we can see that both C and D change across those rows, and A changes, you can see here. The only thing that actually stays the same is this, which is B being 1. So that is going to give us the term B. Okay, now the next biggest thing I can circle is a grouping of 4. So I'm going to circle this group of 4 here. Okay, and I'm trying to make the biggest grouping I can, but it can only be in groups of 2, 4, 8, 16. Okay, so this grouping, I can see that A stays the same and C stays the same. So that's going to be AC. And the last grouping that I can do, just picking a color here, how about orange, is this grouping here, where I can group 4 like that to catch those last 2 that I haven't grouped. And you notice that I'm grouping things that I've already grouped with other things. That's totally fine, right? I can circle something more than once in order to make the largest grouping possible. So A and B change throughout this, this column, but what stays the same is C being 0 and D being 1. So that works out to C bar D. Okay, and as you can see, if I compare terms, that's the same, this is the same, and that's the same. So my Boolean algebra and my Karnaugh map work out the same, provided I got to this point here without making any mistakes. Okay, hopefully that helps.